Latitude by meridian altitude. Meridian altitude can be defined as true altitude of a celestial body when it culminates. Culmination means when the body passes on the observer's meridian. This is also known as meridian passage. Well, let's look here. This is observer on the celestial sphere, that is zenith, the projection of the position of observer, and these are the north and south and east and west points on the horizon. This one is the horizon and the body is passing through this. The moment the body passes on the observer's meridian, and this north and south is the meridian and which is passing through the observer, that means this is the observer's meridian. So as the body passes through the observer's meridian, this one will be the altitude, true altitude when meridian passage occurs, or we can say this one is the zenith distance from a body to observer, that is the zenith distance. Well, in this case the bearing will be either a north or the bearing will be either a south. So this diagram also indicates that this is zenith and this is another diametrically opposite point. These are the vertical circles and this is the rational horizon diagram. Now how it appears on this rational horizon diagram? Well, this is the path of a celestial body like this. When it comes here at the observer's meridian, well, this is the pole. Let me just mark here with some color. This is pole, this is observer here, and this is equinoctial. Equinoctial is the projection of equator on the celestial sphere, and this is the rational horizon, north, east, south, west. This is the rational horizon. So this n to x is the meridian altitude, n to x, and x to z, that is the zenith distance, and we call it meridian zenith distance. That means that is the zenith distance of celestial body when the body is passing through the observer. So we can say that at times a body was here, that means the altitude was 0 and the body has to travel on the path of a declination. Declination is nothing but the equivalent of a latitude on the celestial sphere. So as the body is here, we can say that body will attain maximum altitude. Well, this is the altitude and this is the maximum altitude or minimum zenith distance. Well, this is the zenith distance and this is the minimum zenith distance body will have when the meridian passage occurs. In this case, we should also know that azimuth will be either north or south as I discussed. So the position line will be east or west, like that. We should also note one thing, that this one is the latitude, this one is the latitude of observer, and this one is the zenith distance, and this side is the declination. So we can easily obtain latitude if we know the declination, and if we know the zenith distance, then latitude can be easily found like this. The position line or celestial line of position is the east-west line, and it coincides with the parallel of a latitude. So if we have the meridian zenith distance from a celestial body to observer, and a declination of a celestial body, if we have the declination of a celestial body, then of course we can find the latitude of observer. It should also be noted that the meridian zenith distance is always named opposite to the bearing of a celestial body. Well, we'll explain it further. So let's do this example here. Suppose the meridian zenith distance is 20 degree 30 minute, and the bearing of the sun is 0, 0, 0 degree true. That is, the bearing of the sun is in north, and the declination is given, which is 5 degree south. We need to find the latitude of observer. Suppose this is the equinoctial, which is equivalent of equator, and the sun is here. The latitude of sun is 5 degree south, and observer's zenith is 20 degree 30, and the bearing of sun is 0, 0, 0 degree. That means zenith distance will be 20 degree 30 minute south. That means this is 20 degree 30 minutes south, like this, because it is named opposite to bearing. So we can easily find observer's latitude as 25 degree 30 minute, and that will be south from equinoctial to the observer. This is the line at which observer is located. Same information we can represent on this rational horizon diagram. This is north, this is south, this is east, and this is west, and the body was here, and then the body has come this level. Well, Q to Z, that is the latitude which we need to obtain, and declination is given, which is Q to X, that is south declination. Q, that is equinoctial, to X, that is the celestial body, which is 5 degrees south. Now the zenith distance from X to Z, that is also south, and the value of this is 20 degree 30 minute south from X to Z, and this is opposite to the bearing. We can have a look here. Suppose observer, of course, the observer is here at the center, the body is here, the bearing is north, so X to Z, the zenith distance is south. Similarly, let's do one more example to reinforce this idea, that zenith distance, meridian zenith distance is 20 degree 10 minute, bearing of the sun is 180 degree true, declination of the sun is 10 degrees south. So let's draw this line, that is equinoctial, and declination of sun is 10 degree south. That means from equinoctial the sun is downward, that southward. MZD, meridian zenith distance, is 180 degree true. That means opposite to that, that is north. So from here, from celestial body, we need to go upward by 20 degree 10 minute. So the observer's latitude from equinoctial to this will be 10 degree 10 minute. Sun's bearing has to be is south, so meridian zenith distance is north. I can represent this information with this rational horizon diagram. So this is the equinoctial, this is observer, and from Q to Z is the latitude, while the declination of the sun is 10 degrees south this way, and the meridian zenith distance from X to Z is 20 degree 10 minute north. So we know the latitude will be we need to subtract 20 degree 10 minute minus 10 degrees south, so we get this latitude.